In the very last scene of the previous video on the playlist, I was talking about converting what we have set up here over to integrated circuits instead of using a microcontroller, because really we could do this all with just a couple of ICs and send pure bits back and forth, which is a more typical thing that we would have with a controller. And that is what I had in mind when I mentioned the groupings when talking about putting the protocol together. So while just pure electrical part is on my mind from working on the PCB, I thought about that a little more and decided I do want to go ahead and include those. Just that way we have the sort of values we would normally receive from a controller, just the pure binary form. So let's go ahead and add that into our protocol. And also through this comment in, since the last time the code showed up in a video, I realized those instructions for those valid commands, forgot to explicitly state the instructions need to end with a new line character. So we should probably add that in. So if we come over here and go to our list of valid commands, we could add a couple more on here, which on the list, if you remember that from an earlier video, also had movement to get return 2 bytes of data, 1 byte for each axis, and action, which is going to return 1 byte of data, even though we actually only need 4 bits. It's just when we write our code, it's easier to work with 1 byte at a time. And so that we can work with bytes on the axis, we'll just add 100. So instead of going from negative 100 to positive 100, we'll just go from 0 to 200 and then split it back up on the other side if we need to. We'll see if we do anything with that later. For now, I just want to include it, and then a total. So we add those to our commands. Movement, action, total. And if we do end up going with just the regular style controller, what the total returns is basically what would constantly happen. So instead of giving a specific command for that, the total would be in the else block. So if there's not a specific request, we just send back all the data at once. But for now, I'm going to put it under its own command and might just move it there later if we need to. So let's get started putting this together. And I guess I don't want to forget about the change in the instructions, so we'll start there. So we also need valid commands must end in a new line character. So we got that, and then 3 more command words, which are now right over here. So I'll just copy those, add them in here. Whoops. The little asterisk disappeared and all my alignment got off. There we go. So movement to return 1 byte representing the states of all 4 buttons. Action, that keyword will return 1 byte for the value of each axis. And remember, parentheses mean something to Doxygen, so we need an escape sequence if we want to type parentheses. From 0 to positive 200, whoops, not 2000, instead of negative 100 to positive 100. in and total to return 1 byte for the value of each axis and 1 byte for the states of all 4 buttons. Which, it doesn't take much to realize we're only talking 3 bytes to send all of that. So we can very easily deal with 3 bytes on the other side of our code when we receive that and figure out what the state of the controller is based off, what would that be? We need 24 bits, so we could do a 32-bit number and just base all of our checks off of the range of a 32-bit number to figure out what's going on with the controller. And we don't even need all of those numbers. There's only certain ones, so it would just be a short switch statement to go through and figure out what's going on with it as one 32-bit number that we're not even using. We're only using 3 bytes worth of. So now let's go ahead and put these instructions together on what to return. And like I said, for right now, I'm going to put total as a regular instruction, though we might later put that in the else block so that if there's not a specific instruction, we just return the total state of the controller at once. Because that would be what game controllers typically do, and then the game just grabs that state whenever it's ready. But for now, under a specific instruction, just to make it easier to debug. That way we're only looking at that when we're ready to see it. So obviously we have to make a decision here. Do we want to put those bytes together here on the Arduino one or over in our C++ library? And after thinking about it right now, our C++ library basically, it really is like a virtual version of our controller. Each thing is independent and we just get the value of each control independently. So it's set up like, it seems to me more like it really is a virtual object representing our physical controllers. So I'm going to leave it like that and just grab the bytes, assemble the bytes together here. So we need our 3 other commands. So I'll just copy this, control copy, paste, paste, paste. And like I said, eventually this one called total might just be the else block so that it sends that if there's not a specific command. But while designing, debugging, testing, and all of that, I'm going to leave it on a specific command and we'll just move it over to the else block at the end if we do that. And we'll have something different to do each time here. So total, what were the other words? Well, I'll copy them from the list, that way I avoid any typos. Action, or movement. So now we're ready to put together what these are going to do.